Now coming to the power quality. So we have the analogy with the coffee cup. So if you purchase this coffee cup in a shop, you have the coffee here and this foam here. So exactly in the same manner, the electrical equipments consume their energy. They have the apparent power, means this real coffee plus this foam, this is the apparent power, and this we call it the active power, and this is the reactive power. So for example, this motor, this consumes the apparent power. It uses the real power plus the reactive power. So if we don't put this reactive power supply equipment, so this reactive power component will also come from the main supply. So which will cause heating and losses to the transformers. So it is very essential, in fact recommended, to use the compensator capacitor bands. So you can see, for example, the heating of the transformers in absence of reactive compensation techniques. So all these heatings means higher electricity bills if you own the transformer on your side. Again, the point of demand management. People don't use the electricity in the similar fashion. For example, somebody wakes up here who uses less electricity, then he starts his geyser, washing machines, or whatever, so it increases. And in the evening, the load goes down and this goes less. So the target of the demand management system is to cut off the peak. So a lot of customers ask, will you shut down our important equipment? We'll say, no, we will not shut down, but we will tell the equipment to start a little bit later. So let's see in this peak shifting diagram. For example, in the night the load is like this, then it increases slightly, that is the lunchtime, and it increases slightly again, then it goes down. So for example, if we have our allowed limit is this one, so we have this as the peak, and again this is the peak. So make sure that as soon as you reach this point, no load is switched on. So if you want to switch on this load, so we will delay and we'll say this load will be switched on here. Similarly, this load will be switched on somewhere here or later on in the night. So like you can start your water pumping systems in the night. So it's a real case scenario for a hotel in Switzerland where we have a lot of peaks and they were getting much higher bill. So we have put the Emax controller, means energy maximum controller, and we have shifted these peaks in these areas. So you can see we have filled up these areas. So finally, they were saving about 2,451 Swiss francs. Now is the cost center management. This is very important. How much energy is used by individual department or by individual application. Means I should know how much electricity is being used by air conditioners or by lighting or by, for example, my pumps. So instead of a single energy meter at the main utility side, we have installed also smaller meters in the inside. And these meters are communicating via Ethernet to the central software here. So the idea behind the cost center management is not just to find the culprits. The idea is, for example, a definite department is consuming a lot of energy. It might be possible that this department is having older equipments, and they are very inefficient. So it's time to change the equipment, or for example, the air conditioners are using a lot of energy. So we have to check for the insulation or for the doors, windows. Now coming last to the references where this SCADA system is installed. The list is very long, so I'll go in a very faster way. It's automotive. You can see the famous car manufacturers, Audi, BMW, Mercedes, Volkswagen. Then you have automotive suppliers, banks, chemical industries, data centers, fairs, okay, these exhibition centers, hospitals, insurances, power utilities, semiconductors, the universities. For example, this latest is King Abdullah University of Science and Technology and the University of South Florida, that done last year. In our next presentation, we will be showing the data logging and the remote monitoring facility using SEMS systems.